In this video, we examine how to work with distributions of lead time demand. This is part 3 of a 3-part video set on reorder point. So let's first take the case when lead time demand follows a discrete distribution. So this company, Great Chip Electronics, uses printed circuit boards for making LCD televisions. To maintain high quality and low costs, Great Chip has cultivated a set of 5 vendors to supply these PCBs. To keep its relationships alive, Great Chip orders from a different vendor every order cycle. This has meant that the lead time is not a constant, but varies with each order. In recent times, there have been fluctuations in the rate of internal consumption for the PCBs as well. So, owing to these two sources of fluctuations, the statisticians in Great Chip have recognized a pattern in the lead time demand based on 36 occasions in the past when a replenishment order was placed, and that pattern is given in this table. You can see that this is a discrete frequency distribution table. The values of LD are listed in the first column. These are the possible values. These are the values that have been observed on these 36 occasions, discrete values. And the second column gives us the corresponding frequencies, the number of times that these respective values occurred during those 36 occasions. So Great Chip wishes to minimize its total inventory costs, and that would require to lower the reorder point as much as possible. But if it does that, then it's also concerned that the customers may be not very pleased, because the lower your reorder point, the greater the chances of a stock out. So we are asked to compute what is the mean lead time demand. Second, we should find out the minimum reorder point such that there are no stockouts ever. And third, we should find out the reorder point for a 90% service level. Now let's see how to answer these questions. The first thing to do is to expand the given frequency distribution table by adding 3 columns. In the first column, we calculate the cumulative frequencies. In the second column, the relative frequencies. And in the last column, we write the cumulative relative frequencies. Okay, now let's look at the question of mean lead time demand. The mean lead time demand calculation is very straightforward. We just take the set of lead time values and we compute a weighted average using the frequency values as the weights. So when we do that, we get the mean lead time demand as 1218.75. Next, we have what is the minimum reorder point such that there are no stockouts ever. Now, just think a little bit about this. If there have to be no stockouts, then that is possible only if the reorder point is such that it is always greater than or equal to the lead time demand. If that has to happen with these values, then that is possible when the reorder point is equal to the maximum lead time demand possible, which happens to be 1,350. So when the reorder point is equal to 1,350, there will be no stockouts because the lead time demand will be always less than or equal to that particular value. So this is the answer for part B. Part C asks us what is the reorder point for a 90% service level. Okay, so which means 90% of the time we should not have a stockout. Or it means that at least 90% of the time, the lead time demand must be less than or equal to the reorder point. So what should that reorder point be? So if we examine these values and the corresponding cumulative relative frequency values, we see that 0.9 comes only when we reach this row, and this row has a lead time demand of 1,280. So suppose our reorder point was 1,280, then we can see that 92% of the time, our lead time demand would be less than or equal to that value. And therefore, that helps us to answer part C. So the reorder point of 1,280 ensures or gives us a service level of at least 90%. Good. Now, let's also ask the questions, what would the safety stock be if our reorder point was 1,350? The answer is simple. The safety stock is merely the reorder point minus the mean lead time demand when the reorder point is greater than the lead time demand, mean lead time demand. So this safety stock turns out to be 131.25. And likewise, if the reorder point was 1280, then the safety stock would be 61.25. Okay, so this way you can see how with a lead time demand that follows a discrete distribution, we are able to compute different values such as the mean lead time demand, reorder points for different service levels, and safety stocks as well. Good. Now let's look at a situation when the lead time demand follows a continuous distribution. More specifically, let's take a normal distribution. So here we have a system, a company called Bright Systems, a manufacturer of LED lights, which acquires lamp holders from its suppliers. Recently, it has managed to eliminate the fluctuations in the lead time and made it a constant of 4 days. The daily internal consumption continues to fluctuate and is found to follow a normal distribution with a mean of 400 and a standard deviation of 30 per day. So compute the reorder point for a 95% service level and the safety stock, the reorder point for a 98% service level and its safety stock, and the service level and safety stock if we are told that the reorder point is 1500. So how do we go about computing these things? So given the information, let's first write down that the lead time is a constant and it's given as 4 days. Second, the demand is not a constant, but it follows a normal distribution. Its mean is 400 units per day and the standard deviation is 30 units per day. So given this information, we can think that the lead time demand would be nothing but the demand added over 4 consecutive days when the lead time is taking place. So this means that essentially lead time demand distribution can be got by adding the distributions of demand over 4 days or 4 independent and identical normal distributions. The demand over 4 consecutive days, on each day it's a normal distribution with a mean of 400 and a standard deviation of 30. So if we are adding 4 normal distributions which are independent of each other and which are identical because they have the same mean and standard deviation, then what would we get? We would still get another normal distribution. So the lead time demand therefore follows a normal distribution. Okay, good. So what would its mean be? Its mean is nothing but the mean of lead time multiplied by the mean of demand, and this is 4 into 400, which is 1600. What would its standard deviation be? First, let's compute the variance. The variance is given by this formula. Applying the numbers into this formula, we get the variance of lead time demand is 4 into 30 square plus 0 because the variance of lead time is 0. We are given that the lead time is a constant. Okay, so from this we come to calculate that the standard deviation of lead time demand is 60 holders. Okay, so now we have computed the mean and standard deviation of lead time demand as 1660 respectively. And we also know that lead time demand follows a normal distribution. So let's use all this information to answer the questions asked of us. First, let's plot a normal distribution for lead time demand with a mean of 1600 and a standard deviation of 60. You can see that here I've also indicated the Z values. You know what Z means? Z is the number of standard deviations that a given value is away from the mean of the distribution. So on the right side, you have Z equal to 1, 2, 3, 4, and so on. On the left side, you have the negative values -1, -2, -3, -4, and so on. The first question was, what is the reorder point for a 95% service level and the safety stock? So let's put down service level equal to 0.95. What does this mean? It means we have to identify a value of lead time demand which exceeds the other values of lead time demand 95% of the time. And that should be the reorder point we should set. In other words, that would come somewhere here, and it should be such that this blue line, it should be set at a point such that the area under the normal distribution curve from -infinity until that point should be at least equal to 0.95, or let's say exactly equal to 0.95. So if we are to look up the Z table or use Microsoft Excel or any other software to calculate the value of Z, which would correspond to this, you would get Z equal to 1.645. In other words, this point that we are looking for, which gives us a 95% service level, or which has a 95.95 area under the curve from minus infinity till that point, will be 1.645 standard deviations away from the mean. Okay, so this gives us the reorder point straight away. So the formula is R is equal to mu LD plus Z sigma LD. Right? This is a standard formula for finding a point in the normal distribution. So this comes out to R equal to 1698.69. So if we were to express this as a statement, we would say R is equal to 1698.69 is the lowest value of the lead time demand. That satisfies the condition that P of LD less than equal to R is at least equal to 0.95. In the case of a continuous distribution, it is not, you don't have to say at least equal to, you can say exactly equal to 0.95. Okay, now let's ask, what is the safety stock in this situation? The safety stock would be R minus mu LD, which is 1698.69 minus 1600. And so the safety stock is 98.69. Good. Now let's look at the second question, which just says, what is the order point for a 98% service level and what is the safety stock? So if we were to apply the same method that we did for part A, we would get the Z value as 2.054. So this point is even farther away from the mean than the previous one. And the R value as 1723.23 and subsequently the safety stock as 123.23. Good. The third question asked us to answer what are the service level and safety stock if our reorder point were to be set at 1500. So first let's plot the place where 1500 comes, and that is here. And we see the moment we write, moment we mark this line, we realize, or we can calculate using the inverse function, that here the Z value is 1.667. Z value is 1.667, or in other words, this point is minus 1.667 sigma from the mean of the distribution. So to find the service level, what we need to do is to compute the area under the curve given this point. Given this point, what is the area under the curve from minus infinity till this point? And again, if we go to suitable software, or if we use the Z table, we get this area under the curve as 0.048. And therefore, our service level would be 0.048 if our reorder point was 1500. Or putting it in other words, we would have a stock out 1 minus 0.048, or you can say 0.952, 95.2% of the time we would have stock out. Only 4.8% of the time there would be no stock out in the system. Good. Now let's ask what is the safety stock for this? That is quite easy, because safety stock is 0 when the reorder point is less than the mean lead time demand. We already know that. And therefore, in this case, you can see that the safety stock would be 0. So in this way, we have also learned how to compute the values of reorder point, service level, safety stock, and so on, if the lead time follows a normal distribution. So this video has explained to us how to work with a lead time demand that follows either a discrete distribution or a normal distribution, a special case of a continuous distribution. This brings us to the end of this video. Thank you for watching.